Hello dear students, this is Mr. Hitesh Patel, Assistant Professor LJ Institute of Engineering and Technology. In this video series, we will discuss a subject basic mechanical engineering. Today we will discuss about the types of centrifugal pump and rotary pumps. So let's start. First of all, we know that the centrifugal pump, in centrifugal pump we are converting the mechanical energy into pressure energy by means of centrifugal force for conveying liquid from one place to another place. Okay. So which are the different types of centrifugal pump? So the centrifugal pumps are classified in two ways. The first is according to the type of the casing. So according to the type of casing, centrifugal pump is classified into volute type, vortex types and diffuser type centrifugal pump. And according to number of stages, the pump is classified into two categories. First is single stage pump and multi-stage pump. We will discuss each and every pump in detail. So let's start. First is volute type centrifugal pump. So in volute type centrifugal pump, we can see in this figure the impeller is surrounded by casing. There is a delivery pipe, as a suction pipe is also there. So in volute type pump, the impeller is surrounded by casing and that casing is known as volute casing. The design of the volute casing in such a way that there is gradually increasing in area. Due to that, the water which leaves the impeller with high kinetic energy, there is due to gradually increasing in area, its kinetic energy is converted into pressure head of the liquid, and with high pressure energy, liquid discharge through the pump. This type of pump is mostly used because of its simple construction, but there is less efficiency than any other type of centrifugal pump because of eddy loss. So this is all about the volute type pump. Next is vortex pump. So in vortex pump is the modification of volute type pump, because in volute type pump there is a problem with the eddy losses. Due to the eddy loss, its efficiency is reduced. So for removing that eddy losses, we are inserting one annular space or circular ring between the impeller and the casing, so that there is a conversion of kinetic energy into pressure energy takes place in two stages. When the water leaves the impeller with high kinetic energy, at that time inside the annular space, or we can say that inside the volute chamber, there is gradually converted of kinetic energy into pressure energy takes place. Again that water is entering inside the vortex chamber, and there is conversion of kinetic energy into pressure energy takes place. With the help of that annular ring, there is two chamber formed inside the pump. The impeller, between the impeller and the circular ring, the chamber formed is known as volute chamber, and between the circular ring and the outer casing, the chamber formed, that is known as vortex chamber. And with the help of this type of arrangement, we can reduce around 99% of eddy losses. The third one is diffuser type pump. So in diffuser type pump, we can see that in this type of pump, the impeller is surrounded by number of guide blades. The function of the guide blades are to guide the water which leaves the impeller, and due to that guidance, there is less frictional resistance between the water molecules generated. Due to that, less eddy loss is generated, and with high pressure energy, liquid gets discharged. The arrangement of this type of pump is similar to the turbine, so that this type of pump or diffuser type of pump is also known as turbine pump. Now next is according to the number of stages. According to number of stage, the centrifugal pump is classified into two categories: single stage pump and multi-stage. In single stage, it has only one impeller, and that impeller is mostly used for lower head and lower discharge. But in multi-stage, multi-staging is done by adding impellers of identical construction in series on the same shaft, or impeller in parallel arrangement on different shaft. Multi-stage centrifugal pump are classified into two types. The first one is impeller in series and the second one is impeller in parallel. In impeller in series, number of identical shape impeller are mounted on a common shaft. All the impellers are enclosed in a single unit or inside the single casing unit. While in case of impeller in parallel, number of impellers are attached parallelly, or we can say that number of centrifugal pumps are attached parallelly and the line will be common. So that is the arrangement which is known as impellers in parallel. Submersible pump is the best example of impeller in series. Next is priming. So priming is the process of filling the suction pipe, casing and discharge pipe to the discharge valve with the liquid before starting the pump. This topic we have already discussed in last video session. The priming is done four methods. With the four methods, the first is manually priming, second is primary priming with vacuum pump, third is priming with jet pump, and the last is priming with air separator. In manually priming, we are supplying the liquid manually and fill all the space like suction pipe, casing and discharge pipe up to discharge valve. In priming with vacuum pump, one reciprocating pump is fitted at the end of the delivery valve, and with the help of that vacuum pump all the air will be removed from the pump, and due to that negative pressure the suction of the liquid takes place and all the pump filled with the liquid. In priming with jet pump, a overhead tank is provided. Whenever we need to prime the pump, at that time the valve will be open. With the help of that liquid the pump will be priming done. The next is priming with air separator. In priming with air separator, a bent tube is fitted at the at the suction side of the centrifugal pump. Due to bent shape, the necessary amount of water is already stored whenever we close the or we switch off the pump. During the next operation, again that the water which stored in the band shape will use to do the priming, and the air separator is provided at the top of the pump. Then air separator will only allow air to pass and water due to high density will again enter, and due to this there is a priming in centrifugal pump will be done. Next is bucket pump. We know that bucket is a type of reciprocating pump. So in bucket pump, we can see that if non-return valve is fitted over the piston, such type of arrangement is known as bucket. And in bucket pump, there are total two stroke. The first is intake stroke and the second is discharge stroke. In bucket pump, we can see that at the end of the suction pipe a non-return valve is fitted. At the starting of delivery pipe non-return valve is fitted. There is a handle is provided which is used to reciprocate the piston inside the cylinder. So whenever we press the handle in downward direction, due to that the piston will travel in upward direction. Due to that negative pressure is generated inside the cylinder or downward portion of the piston, and due to that the suction valve will remains open and the bucket valve or the non-return valve provided at the top of the bucket will remains closed, and there is suction of liquid takes place inside the bucket. During next stroke, the handle will press in upward direction. Due to the pressing handle in upward direction, the positive pressure is applied over the suction valve which provided at the suction pipe so that it will remains closed, and due to that the piston, the bucket or the non-return valve which provided over the piston will remains open, and all the liquid from downward side of the piston will travel to the upward side of the piston. Till this stroke we are not getting the discharge. Again piston will travel to the upward direction by pressing the handle in downward direction, and due to positive pressure over that valve provided on the piston, the suction valve will remains open. Then suction of the liquid takes place and the liquid which is over the top portion of the piston will get discharged through the delivery pipe. So by this way we can get discharge. By using the bucket pump, we will not get continuous flow. We will get intermittent flow by using bucket pump. The next is Vane pump. So Vane pump, gear pump are used for pumping highly viscous fluid. So this type of pump comes in the category of rotary pump. In Vane pump, there is a stationary cylinder is there. Inside the stationary cylinder, one rotor is fitted. In that rotor, number of grooves are there, and inside that groove, number of sliding vanes are fitted. That vanes are made from the plastics, fiber or metallic material, and that inside that stationary casing, the cylindrical rotor is fitted eccentrically. Means the center of both the stationary casing and cylindrical rotor will be different. Whenever the power will be transferred to that rotating rotor, at that time, due to rotation, the centrifugal force is generated, and due to that centrifugal force, the vanes comes out through the grooves and one pocket is formed, and due to that there is a negative pressure is generated, and there is suction of liquid takes place, and that liquid will be trapped inside the pocket, and when the pocket comes near the outlet side, the liquid will be discharged. This is the basic of an pump. So let's discuss Vane pump in detail. So it consists of stationary casing and cylindrical rotor. The cylindrical rotor contains number of sliding vanes which are fitted to the radial grooves of the rotor. The vanes are free to move away from the center of the rotor due to spring action and centrifugal force of the rotation, and this makes the tight contact between the vane and the casing during the rotation. When the rotor is rotated, the liquid is enter from the suction side and entrapped in the pocket which generated between the vanes, and the liquid will carried out by the vanes and finally discharged to the delivery side. So this is all about the Vane pump. Next pump is gear pump. So gear pump consists of two gears. One is driving gear, another is driven gear. When the power is supplied to the driving gear with the help of prime mover, the driving gear is rotated. Due to that, the driven gear is also rotated but in opposite direction, and an airtight casing is there. Due to this rotation of mechanical elements, or we can say that gears, there is a negative pressure is generated at the inlet side, and the liquid which is highly viscous entrapped between the gap of the gear teeth. Okay, and when that gear teeth will reach at the near about the outlet portion, with high pressure energy liquid gets discharged. So as we have discussed, it consists of two gears which are meshed with each other. The rotating gear provides the pumping action. When the pump is primed, the liquid fills the space between the teeth of the gear at the suction side, and when the driving gear is rotated, another meshing gear is also rotated but in opposite direction, and a negative pressure is generated at the suction side due to rotation of the gear, and due to pressure difference in fluid tank, the suction pipe causes fluid to run from the tank to the pump, and there is a discharge of the liquid takes place. So this is all about the gear pump. If you have any query in these pumps, then you can write down your queries in the comment section. I will definitely solve all your queries. Thank you for watching my video.